It's happening. Be cool. All right, so polyatomic ions on the back side. They're on the back side of your sheet, and I don't like the way that those are listed. I'll try and get you a better set of polyatomic ions for you to use. Actually, probably be a new periodic table. But polyatomic ions are groups of ions that have a charge, groups of atoms that have a charge. Most of them are negative. Negatives are called anions. All of these are negative. You can see that most of these are negative. This whole half here is negative. But polyatomic ions, you treat them like regular ions. You can crisscross them. They have some special names, which we'll get to in a second. But they are, for all intents and purposes, just like any other negative ion, fluorine, chlorine, bromine, whatever. They have different charges. You can see some of them are like +1, no, that's not a bad one. -1, -1, -3, -3, -2. They're all different. And the charges are listed there when you need to crisscross them. If you remember, you probably don't because it's been so many days ago. But when you're writing ionic compounds, you crisscross the charges. You have a positive ion, which is called a cation. Yep. And then you've got a negative ion, which is called the anion. I was hoping for more meows there, but it didn't happen. This piece of paper is your list of the most common polyatomic ions, but there's more. And like I said, I prefer to give you this one, but I don't have them yet because I just noticed this is what you have. So I don't like this because it's like not in any real order except by charge. This one is in order by the formula on this side, and looks like it's in order by the name on that side. And I mean, I'm sorry, alphabetical order. By formula, alphabetical, by name. So there's some crossover here. I can get you a better one, don't worry. So how does that work here? Well, we're going to come back to that in a second, but let's look at what we did last week, which is really case 2. See case 2 here? Let's start there. Should I turn this light off? It's happening. It's done. It happened. Okay. When you're going to write the formula for something like, let's say I said sodium chloride, and I want to know what its formula is, this would be sodium chloride. If I gave you that first, okay. And I said, write the formula for it. If you, just to refresh your memory, you would go and find sodium on a periodic table, right here. And you'd say, oh, sodium, it's in the first group, so it's +1. So you'd write Na +1 like this. And you go find chloride, which is really chlorine, which is in the -1 column right here. And so you'd have Cl -1. And then what do you do next? Remember? Crisscross is what you do next. These are the same charge, they just cancel out. So they're opposite charges, they cancel out. So you have Na plus and Cl minus, and you just get NaCl. Likewise, if I'd said to do write the formula for barium chloride, and I gave you this part here, well, you'd go to barium here, which is in the second column. It's a +2. Chlorine is still -1. Take the 2, put it there. Take the 1, put it there. Don't write the 1s, and you get BaCl2. Naming them is easy. If you're given a formula like this, and you want to name it, the rules are right here now. You also have them in your notes, but the metal has the same name. Non-metal gets an ionic name, which means an IDE name, in case you care. And you don't worry about numbers. So if it says NaCl or BaCl2, it doesn't matter. You don't just ignore that. If it said, you know, let's see, let's make one up. If it said Ba3N2, you'd still call it barium nitride. It wouldn't worry about the numbers at all. Again, that's a review. Is that helpful as a review? As I mentioned to start the hour, you also can use things off of the polyatomic ion list. So something like, if I said, write the formula for potassium sulfate, if we're going from the right to left, naming it first, and then writing the formula, you write the charges first. Potassium is right here in the +1 column. That's K +1. Now here's where things differ. Sulfate, notice it ends in ATE. Any different ending, ATE, ITE, yeah, not IDE though. because sulfide would be sulfur if it ends in IDE. If it says sulfate, you're looking on the polyatomic ion list, which is very, very bright. Okay? And I guess just stick to the right side. Sulfate, if this is the alphabetical order right here, and you can see sulfate is right there. And its formula is SO4, and it's got a -2 charge. Be careful, because there's also sulfite, ITE, which is SO3, and right above it there has a -2 charge as well. We want sulfate, though. So potassium +1, and then sulfate SO4 -2. The 4 is part of the sulfate's formula, so you're never going to change that. So don't change it when you crisscross. You just want to do everything the same now. Take the 2, put it there, take the 1, put it there, and you get K2SO4. So far, so good? Okay. If you do crisscross and you need a number out here in this little circle, then you do something different. So let's look at that case, like for barium nitrate. And some of these polyatomics you would be familiar with, like for example, who is drinking a Mountain Dew right now? Anyone? Or any soda? They're so healthy. No soda in there either, but like phosphates are in your sodas. Phosphoric acid is a preservative. Sodium phosphate is also a preservative. Nitrates and nitrites are in your hot dogs. So these words, you've probably heard them before, phosphates and nitrates in the soil. They're pretty common from lots of those polyatomics. But barium nitrate, barium is +2. Don't get confused. If it ends in anything that's not IDE, you're looking here on the polyatomic ion list. Okay? Some of them do end in IDE. For example, hydroxide, that's on this. Or cyanide, that's also on this. But for the most part, IDE means periodic table. And anything else is going to be on the polyatomic ion list. So nitrate, did you find it? Did you look?
Anode.
I'm heartbroken. You looked? Yeah, it's NO3. What's its charge? -1. Okay? And then when you crisscross it to find the formula, 2 is going to go down there, 1 is going to go over here. You can't just, whoopsies, you can't just write this though, BA, oh, I already blew it. You use parentheses to separate the 3 and the 2. Whenever you have more than 1 of something off of here, you're going to use parentheses. I'll say it again, whenever you have more than 1 of something on the polyatomic ion list, you will use parentheses to write its formula, because this makes no sense. You can't just write BaNO3 because what does that mean? It means you've got 32 oxygens, which is too many. But this means you've got 2 of everything in that parenthesis, which is an NO3, which you've seen before when we've done some when we've done molar mass. You've seen this nomenclature before. Want to try one? Where are we at? What's a good one to try? How about, okay. How about aluminum acetate? Want to try it? Oh wait, I should tell you some secrets about aluminum though. Some of these, even though they're transition metals, they have some exceptions. They always have a charge, 1 single charge. We know that this is +3, ±4, -3, -2, -1. But there are some that are in the middle that actually are exceptions and they only have 1 charge, and aluminum is one of them if you want to write them down. Aluminum is always +3. Zinc is always +2, so is cadmium below zinc. And then to the left of that, silver is always +1.
What else would it be?
Well, we're going to get to that in a second because transition metals can have more than 1 charge, but these 4 transition metals, they only have 1 charge, so you don't need to treat them as regular transition metals. Great question. So when you're crisscrossing this, aluminum, you'll say, oh, aluminum is, well, you're going to do it now. You know what aluminum is. I guess we just found it. And then you say, okay, well, acetate, I'm just going to find that on the periodic table. Where's the box for acetate? Is it on this side? It's on the other side, right? Because there's no box for, if you want to work backwards, like, I can't even finish it, I guess. It'd be a bad word. So, find acetate on this page, then crisscross them, then be done. I'll give you a minute to. Aluminum acetate? Acetate. On this right-hand column right here, they listed alphabetical by name. So look for acetate, which would be right up here. Look, I found it. Minus means -1. So it's C2H3O2. It's got a -1 charge. Now what do? That I've done this step. Good answer, crisscross. Take the 3, put it there. Take the 1 and put it there. And don't write the 1. And you will get AlC2H3O23. No, parentheses, right? Because you used more than one of something off of here. So you'd use parentheses for it. So that is the formula for aluminum acetate. Want to try another? Try the one above it. Magnesium hydroxide. I'll give you a hint. There's no hydroxium right here. Okay? So you're not looking from the front side, you're looking on the polyatomic ion side. Magnesium hydroxide. There you go. Magnesium is +2. Hydroxide ends in IDE, but it's one of the exceptions that's on the polyatomic ion list. It's OH -1. So 2 goes there, 1 goes there. You're going to get something like MgOH2. How many of you have it like that? Okay. Well, unfortunately, that 2, if you write it this way, only applies to the H. Okay? So anytime you use more than one of something on this list, you should parenthesize it. So it should be this, which means you've got 2 O's and 2 H's. So if you write it without a parenthesis, like on a quiz, you get half credit. To get full credit, you want to make sure that you include the parentheses. Last hour, can we just put parentheses on everything? And the answer is no, that's not how it works. So you need to know when to use them and when not to use them. And the answer for the 5th time, whenever there's more than one of these, you should have them in parentheses. That rhymed. Okay. Naming is easier because you don't change these names. So if something is on here, leave it and just write down what it is, like in this example. Okay. You name the first one still, which would be barium. And then you look, there's only ever 2 things. So sometimes this thing on the right side is on the periodic table, and you would give it an IDE ending, like in this one above here. And sometimes it's more complicated. And the more complicated it looks, the better chance that it's going to be on this piece of paper. So you're looking now for NO3. And you would say it's nitrate, because I did this example right up here, actually. So you find NO3 on this sheet, which is right here. Nitrate has a -1 charge. The charge is not important for naming. That's not factored into naming at all. Then you just don't change that. You just leave it the same. There's no IDE. You don't call it nitrate-ide. You just call it nitrate. So in some respects, that's easier because you get to leave it alone. Why don't you try the one above it? So name the first, which is sodium. Does it matter that it says 2 there? Nope, not for naming. And then SO3. Now we got to find SO3 on this piece of paper. And SO3 is down here. SO3 has a -2 charge. Again, that's not really important, but you can see that it's written as sulfite. So we call it sodium sulfite. Done. That's it. Questions about some of the new things there?